This is lab 3, and we're going to be looking at separation. If I come over here, I'm under week 2 for lab 3. This is on page 49 of the lab manual that it starts. I have it pulled up here on the lab manual on the side. You're going to be doing the worksheet posted below. Sorry, my nose is stopped up. So that'd be this link right here. This will pull up the document. And for your video, just show kind of, it's not showing the right thing. Just show, the setup of everything and then explain to me your separation technique, how everything kind of worked, just in general, really quick. Okay, so let's go back over here. We're going to be looking at separation. And this is separation of a mixture. You could read through this, but basically, a mixture is something that can be, what's the word I'm looking for? It can be broken down into further parts. It's basically, you combine pure substances together and you can separate them. So a good example I always use is salt water. Okay, so if I have a cup of water, put some salt in there, and you mix it, and the salt dissolves, right? And it's a homogeneous mixture, so it looks the same throughout. You couldn't actually tell that I put salt in there unless I told you. But I can separate salt and water afterwards. I could set, for example, the water out for about, I don't know, a week or so, let it evaporate, and what's left over at the bottom? The salt. Okay, so it's a way of separating them. So as long as you could separate, the full components, it's a mixture. Now, if it's actually a chemical reaction and you made a new product, you can't separate it out. That is your new product. So if you mix baking soda and vinegar, for example, those react together. Think about your volcano, you made it when you were little or something. You now made this new substance, and you can't separate anymore baking soda and vinegar. They're not in the solution anymore because they've reacted together. Now the mixture, they don't actually react together. They will mix together, meaning, they'll, let's see, basically they'll mix, but they don't react, okay? They have no reaction to each other. They just sort of mix up. Okay, so we're going to be separating a few things. We're going to have water, and in here we're going to have, you see, sodium chloride, benzoic acid, silicon dioxide, and iron powder. We're going to separate all of those, and this is going to be based on solubility. Solubility is the extent at which you can dissolve in water, basically. So how much can you dissolve in water? Here's the solubility table of sodium chloride. If you see here, at 0 degrees Celsius, it's about 35.7 grams. So at 100 milliliters of water, 35.7 grams of salt, sodium chloride, will dissolve in water. If you look here, room temperature is between 20 and 30, and you see it's about 36-ish. Notice as the temperature goes up, you can dissolve a little bit more. Okay, now if we look at, let's say, benzoic acid. Benzoic acid, I don't have a whole table, but let's just compare. It said benzoic acid, its solubility number is 6.8 per 100 milliliters at 95 degrees Celsius. So let's look here. For salt, 95 degrees Celsius is between these two here. So let's say it's about, I don't know, 39 grams per 100 milliliters for salt. But for benzoic acid, it's 6.8. Do you see that a lot less? Only 6.8 grams will dissolve versus about 39. Okay? Now let's look at 10 degrees Celsius. So right here, for sodium chloride, it's 35.8 grams will dissolve versus only 0.2 grams. So if we look at these numbers, what do they tell you? They tell you that salt, sodium chloride, is can dissolve a lot more readily in water than benzoic acid. Salt dissolves pretty well, benzoic acid does not. And the reason is, we haven't really learned about this yet, but let me just kind of, blow your mind if you want. It would be intermolecular forces. Intermolecular forces are the attractive forces between different substances. So even though you don't know them yet, let's think about this. Okay, so salt, sodium chloride, and water dissolve together really well. You can see here, I mean, quite a bit of salt dissolves in water. The rule is like dissolves like, okay? So let's think about that again. Sodium chloride dissolves well in water, so that means sodium chloride is like water, okay? So sodium chloride, the interactions must be very similar to that of water. Now let's look at benzoic acid. Now benzoic acid does not dissolve that well in water. It dissolves a little bit, so there's a slight interaction there, but not that well. So that tells you that benzoic acid is not that much like water, okay? Because it won't dissolve. Let's also think about oil and water, okay? Oil floats on water. It is not attracted to water at all. Even if I shake it up, it'll eventually separate out again, right? Okay? So do you think oil is like water? No, it's nothing like water. So remember, like dissolves like. So if something dissolves in something, that's because its structure, its makeup is very similar to what it's dissolving in. So you'll be doing some solubility testing here and some separation, and you can kind of get an idea of what is a lot like water, and what dissolves best in water and how to separate different things. Anyway, so I hope you have fun.